All right, last time we left off, we were working on our database with adding multiple tables, and I think we left off with setting the relationships. Did we do that? We did that. We talked about referential integrity, where if you delete a record out of one table, you have to delete the related records out of the other, because otherwise you have these records that don't point to anything. There's no, the information becomes incomplete and therefore useless. So what we're going to do today is look at, and here's what I've done. I've taken this is an older version of the same database. It's basically got the same fields in it, but I've got a lot more data in it. And so I have a courses table, I have a students table, I've got more students, and a schedule table where people have signed up for different courses. Now, when we have data in a database, let me ask the question, what makes that data useful? What makes it useful? Who cares about all this stuff? I'll give you a hint. I'll bet Jim Smith and Todd Boyle and Joe Pendergast think this is pretty important. So what makes this stuff important, useful?
The students make it important.
Right, or the users of the data being able to access and get the information out in a useful way is important. If I just printed out these three tables like this, it would take some doing to figure out who signed up for Business 3100. All right, I could figure it out, I guess, but going through a big printout of just student ID numbers and course ID numbers, and then especially if I wanted to figure out who the professor was for the course and all that, it becomes unwieldy, especially now multiply that by 40-some thousand students that go here. There has to be a way to digest the relevant information down to something that a single user can find value in. So that's a big part of this. Now, one of the ways we do that is that we can create queries. A query is just basically a question that you ask of the data. So what I'm going to do is, let's just put this here and then close that. I'm going to change the view because there is, what this workspace here is very similar to the relationship screen that we looked at last time, where we can, if I pulled out all of the tables, where's my show table? If I pulled out the other tables, schedule, double click on them, and courses, right? I have all the stuff here, and I could, create queries from that in a visual environment. This is a visual representation, and we'll see how that works later on. In the Access Workbench, did you guys have to do queries yet?
I started and I did the first part, the first like SQL, so I have that on my screen.
Okay.
I didn't go into the next part, which was the thing with the B. QBE, I didn't start that.
Query by example.
Right, but I did the first exercise for the
Okay.
SQL.
All right.
Query.
SQL is a language that was designed to access databases back in the 60s. When they first started, computers first started showing up in businesses, and they were accumulating all this information, and then the question became, well, how do we get it out? And get it out in a way that makes sense. So IBM created SQL, or sometimes called SQL, as a way of doing that, basically asking questions of a large database to get very specific information out. And that's where its value comes in. So if I wanted to create a query, what I would do, using SQL this time, what I would do is create the query, and then this is the sort of the design view that we're looking at right here. I would switch my view, there's another view, because there's data sheet view, which is what we're used to, like with the tables, switch to SQL view, and I would love it if I could get this to zoom in a little bit. Maybe I can, no.
And I did have that experience, and I typed in the select and the from, so that I ended up with a chart.
Okay, so what I'm going to do is I'm going to just refer back to my student table just so I can, and actually I'm going to put that in design view. So when I refer to the fields in my student table, I have to refer to them by field name. I can't refer to them by the caption, the column headings here, because they are likely to be different than the field name. Because remember, we had the last space name and first space name for fields that were first name, last name, all run together. So I want to make sure I have access to the field names, because when I create my query, I'm going to be using those. All right, so I'm going to just see if I can find text formatting. That's not going to let me. Well, all right, I'm going to be stuck with this. It's going to be a little hard to read, and I apologize for that, but we'll get through it. So what I'm going to do is a simple select query, because select, so in SQL or SQL, one of the big requirements, big needs, was being able to extract records from tables. So the select statement is pretty important. That's probably the first one that they worked on. What you do is you want to say select, then a list of fields from, no, you don't have to capitalize, from a list of tables, oops. Then you have a way of, so if I said select student dot first name, student dot middle initial, student dot last name from students, that's going to give me every student. And if I was doing it on the real USF database, that would give me a lot of students. So I might want to reduce that. So select these fields from these tables. I use a where clause, where, and then some condition. So what that does is it will give me a list of records that meet that condition. Where major equals business, where gender equals female, whatever, okay? Where GPA greater than 3.0. Okay, and then finally, if the list is long enough, and maybe I need a long list of, like, one of those introductory chemistry classes that have like 500 students in them. They still need all those students, but maybe they sort them a certain way. Order by some criteria. So some expression. All right, so a basic select statement has I'm going to select certain fields from one or more tables where some condition is true, and then I might order it by some other, order by last name. Okay, let's do this. So So I'm going to just select, do a simple select from my students table. Select student dot, I don't have to, first name, comma, student dot last name, oops, name, and you can put them on from. So I put select, and then the fields on the top name, top line there, and then from student is the name of my table. And let's run this. It's just very simple. Just run this one, and we'll see how that goes. So if I have to save it. So I'm going to save this, and I'll call it student query. You should try to make your queries something descriptive about what it is that it's going to give you. If you just say query 1, query 2, query 3, then you have to remember what query 1, query 2, query 3, and once you get past 3 or 4 queries, you don't know what they are anymore. It's not intuitively obvious what they are by looking at them. So I save that, and notice in my access objects, I have my tables, and then I have queries, and then my student query is listed there. So now if I want to run it, yeah, it's open by me.
I had that where I was playing with it, and you actually have to click on that X over on the right.
Here?
Yeah, and then you can actually run your report, your query, whatever.
There used to be a run button. Run, no, that's a run macro. Oh, man. Oh, here it is. There. It's under design. Why? I don't know. So I'm going to run this, which basically going to switch the data sheet view. Come on. It's going to make me close this. Oh, God. That, design. Table student, oh, I see what it's doing. I have to close the student table. Now if I change this to SQL. No. Close it all. Student query. Open that. There, that finally ran it. But that's SQL view. All right, there's my run button. Hit run, and it runs it. So in my statement here, select student.firstname, so table.fieldname, student.firstname, comma, student.last name from student. Now, I also might want to include, so if I go back to my SQL view, and then look at my student table so I can see the design view of that. I have the major in here, and maybe I want to add that field. So, comma, student dot major from student. Now if I change my change that. Maybe it's case sensitive. I used a comma instead of, I wish this thing would let me make the font bigger. So student dot first name, student dot last name, student dot major from student, run it. So now I have their majors. Added another field. If I wanted to look at just the business majors, how would I modify this? Based on our template here.
Order by criteria.
Not order by,
With a where do condition that you have, right?
where,
Or major than business.
while, where, student dot major equals business. And I think it is case sensitive. Where major is business. So where student dot major equals business. So now that's not going to, when I run this thing, don't get scared. I didn't delete all those other students. The only thing it did was just sort of filtered them out. It's just, I want to look at this table in a particular way. Some database systems call it a view. This is where you want to view a table in a certain way. And there are records that I don't want to look at. I don't delete them. I just don't show them. So that's what's going on here. So those other nutrition and chemistry majors are still existing in that student table. It's just this query is only going to show me the ones that meet that criteria. All right, so then I can add to that. Go back to my SQL view. Finally, I can order by student dot last name. All right, so that fills out my last. Run that. So now I have all business majors and order by last name, Boyle, Kidd, Ripley, Serber. SQL is a very English-like language, and most times you can look at a query and say, I kind of know what that does. You know, if I said select student dot first name, student dot last name, student dot major from student, where student dot major equals business, order by last name. See, it's kind of intuitive. It gives you at least a sense of where you're going from there. Okay. Now, I might also want to look at the courses that students signed up for. So I might want to add in another table. So if I look at my other, see, I have my schedule table, and put that in design view. My schedule table, where I have a course ID, and maybe I want to look at their grades. I don't know if I have grades in here or not, but it's all right. So at the end of the semester, maybe I want to look at the grades that a student has. Certainly a student wants to do that. So what I do is I link in or join the schedule table with the student table, similar to what the relationships screen did. That's just a visual representation of doing a join, what they call an inner join. And it looks like this. So, student first name, major, schedule dot course ID, comma, schedule dot grade from student, comma, schedule. So I have to include both tables. Then there's an inner, and there's a couple ways to do this. Inner join. Student dot student. What field am I going to join these two tables by? How would I connect my schedule table to my student table? What field? Yeah, but course isn't in student.
Oh, that's right.
What field is in both?
The student
Student ID,
ID.
right? And that's unique in the student table, so that will get me one student for each one that I put in there. All right, student ID. Entering student ID on, I'm doing this from memory, on schedule dot student ID. That doesn't sound right. This could blow up on me, but that's all right. I have another way of doing this, if this doesn't work the way I want it to. Join expression, that's about it. Let me do another query to do this, so that I don't want to mess this up. Go ahead, leave that. Create, and I'm just going to do this query design. I'm going to kind of cheat the system a little bit here.
So you created it, and then the SQL view gave you the codes?
Mm-hmm.
I like that.
I want you to learn SQL, though.
Well, no, but I think while you're learning, if you can check your work, like a math problem where you
Yep.
have, you know what I mean, where you can go back and you can see what you did wrong.
All right, I see what I did wrong. From student, I'm going to join schedule on student ID, student ID equals, there we go, I had it. It's one of those things, if you don't do it all the time, you get rusty. I took an advanced database class in graduate school. It was nothing but SQL programming. For a whole semester, all we did was select all, and insert and delete, and it was like we were speaking SQL to each other after a while. It was just endless thinking in SQL. So let me see if I got this right this time. Let me just run this before I, oops, cancel. And if you get the field names wrong, it's going to hiccup on you. Schedule. Mm-hmm. I can't believe I did that. Here's what I did. I did this a long time ago. So I accidentally put a space in the field name course ID. Here's what you have. Here's why I don't do that normally. If you put a space, you can call your field course space ID if you want. But when you're writing SQL code, when you want to say schedule dot that space throws it off. So you have to put square brackets around the whole thing. That's why I don't put spaces in field names. It just, because it came back to bite me right here. And I did this database a couple semesters ago because I put a lot of data in it, and it helps when you're trying to do things like queries. And that's what happens. Let's try it now. All right, so Yeah, let me get this. Yes, all right, this works. Go back to my SQL view. Select student.first name, student.last name, student.major, schedule.course ID in square brackets, schedule.grade from student, so it's from the student table, inner join schedule. So I'm joining those two tables on, so when I have an inner join, it looks like this. I have my from clause right here, from student, inner join schedule, that says schedule, on, and then I have to have an expression to join them, okay? So I'm going to join this table with this table on the expression student ID equals schedule student ID, right? Because those tables they have the same field, right? They have student ID in the student table, and you have a student ID in the schedule table. So where the data is equal in those fields, join the relationship. So this is how you do an inner I-N-N-E-R, join. This thing doesn't like my handwriting. So it's inner join. That's one way to join tables together. All right, and as you see, when I run this, all right, now I have a question for you. How come Ann's name shows up 4 times and Jim shows up 4 times and Tim shows up 4 times? If I go into my student table, Ann's in there once.
It's not sorted by how many courses they have or anything like that. When you look at the student table, you're looking at just the students, not the classes.
Right. So when you look at the schedule table, what's Ann's? Ann's student ID is 5, 6, 7, 8, 9. So if I look at the schedule table, 5, 6, 7, 8, 9 shows up here, and shows up here, and here, and here. So her student ID number shows up more than once in the schedule table, and every time it refers back to the student table to get the rest of her information, it reads her first name and last name. So it rereads the same information over and over again and displays it multiple times, but it's still stored only once. This is really the power of a relational database, being able to store once, but I want to use it a whole bunch of times.
Because this is interesting, I started fooling around with the Google contacts and putting them in categories, and it made me think of class when I was doing that, because now I can say Algonquin Services, and then I'll get a list, or I can say restaurants in Clearwater, and I get a list, right? And then if you put the 2 groups together, then you get both from the 2 different databases, basically, or lists. And it just kind of helped me understand what we were doing in class when I started fooling around with what I hadn't paid attention to before on my contacts list. It's
Kind of neat.
a light went out.
No, any way we can get that to happen, we're all for it. The light goes on. And I've sorted, what did I sort this by? Student last name, right? So what you have here is all the courses for Ann grouped together, and all the courses for Jim grouped together, and all the courses for Tim grouped together, because it's sorted by last name. The other way you can do this is this is the old-fashioned way, so to speak, instead of doing inner join on schedule, I'm going to say from student, comma, schedule, and then where, you can use the where clause, where student ID equals student ID equals schedule, schedule ID, student ID, sorry. And then I can use and to join the two conditions. So I can use my where clause. So I say, when I go back to this here, select fields from tables, where condition, what I can say is where student.student ID equals schedule.student ID, which does that join. That's actually I think it was the first way it was created when they created the language. Then they introduced inner join afterwards. So I do that. That's part of the first part of my where clause, and student major equals business, and this should work exactly the same way. So there's two ways of joining tables together. It's actually more than two, but to do the same basic thing, to join them so that you can get a query out of it, to see. In this case, I wanted to see what courses are my business majors taking. How are we doing with this? When you have to write your own code, it's a little different. But I know I kind of tipped my hat a little bit by saying, okay, I went into my design view and created the same query as I tried to do writing the code, then I just changed the view to SQL and it gives you the answer. Try to refrain from doing that as much as you can. If you get stuck, then do it.
I think it's a good way to just kind of put it all together in your head, and then if you have a small error, you can look and find it more easily if you know how to do that than if you're just muddling around trying to figure out that maybe you left a space, which you could
Yeah,
down completely.
and I had my problem was when I forgot the brackets around course ID. It thought it didn't know what to make of that. So when I tried to run it, it says syntax error, missing operator in query expression, schedule.course ID. So I had to fix that. It hit the word ID and it didn't. So well, I don't know what this is. So I put the brackets around it. Now, if you had no experience with ever debugging SQL code, and SQL doesn't always give you a helping hand. It just says, I got to this point and I don't know what happened after that, and I don't know how to proceed.
And for us, we can know the good way to avoid that is to not have that, make sure you have a capital C and then run them together and have capital I. And then you don't have that ordeal at all in your table.
Right.
Right.
Yeah, if you
If you name it.
I don't think the table, the table names and the field names are case sensitive. I don't think they are. I can always
Well,
test
you
it.
said case sensitive is good, or the space causes the problem.
Yes, the space.
However, by having a capital, it makes it easy to read.
Yeah, I think it does.
Is what is meant.
Let me try this last name. I'm going to lowercase last name and see if it still runs. It does. So
It's just making it easier for you to read it.
absolutely. Any way that's easier to read it
Matters.
is good. I, as a habit, I tend to capitalize the commands from SQL commands. Select, I capitalize the whole word from inner join, so that it kind of, when I write the code, if I go over here, go back to my SQL view, when I write the code, see how I have select on the first, select, and I have all my fields on the first line. From, and all my tables on the second line. Where, and all my conditions on that line. Order by, and then all my sorting or
And it
conditions.
goes back to that, it's to read and understand.
Yep.
You're keeping it in the system. It might work if you ran it all together, but it would be harder to find an error.
It certainly would, and it's harder to. I'm a big proponent in the programming classes I teach that you write your code so that it's easy for you to read. Who cares how the computer has to read it? As long as the computer can read it, you're fine. But you should write, indent and group code together and put some vertical spacing in there. Make it easy to read, because that's what you're going to want.
And if you had to bring on another set of eyes to help you figure out what's wrong, then it would be easier for them to
Right.
figure out.
Access, when it creates these queries, it just keeps going. It doesn't care, because it's the program's the only thing that has to look at it. But when I write code, I sometimes will even skip a line, make it even more readable, and that runs just fine. Doesn't matter. How we doing? Not bad. Not bad. Let me see what else we're covering. What chapter are we in? I want to make sure I don't leave anything out. We in chapter 3 now. How are you guys doing with the Access Workbench stuff? Is
I
that
think okay.
easy to understand? Does anybody have a version of Access newer than 2013? No? Okay. You have 2000, okay. I was just wondering if the 2015 version looks the same as what's in the book. That's what I was, but since you're using 2013, that's great. That's terrific. All right. Let's create a table just for fun.
Am I jumping the gun line to know more about the QBE?
Query by example?
Yeah, is that next week?
That's this.
Okay.
That's that.
Oh,
This is a graphical or a visual interface
right.
that sends information to what they call an SQL jet engine.
Okay, so when I start working on this, I'm going to expect to see those sorts of
Yeah.
in
Yeah.
the workspace. like-
Query by example is
Yeah.
this. One of the things I like about Access is this screen here looks just like that relationship screen that you first joined the tables.
Right.
And once you join the tables in that relationship screen, and then I show another table on here, let's say I pick the courses table, the links automatically fill in.
Right. But it
Yeah,
makes it easier to understand and it flows nicely.
sure does. And it's just, so, and this, from here, you just pick the fields you want, and they show up down here in the bottom. You can change the order of them, you can,
Well, I found myself just trying to see what somebody might be interested in a report, so I was fooling around with taking things out and putting things in, like as if, well, I wanted to know this. Well, no, I don't want to know this, I want to know that. Or how do I change it so that they don't put a bunch of crap in there that I'm not interested on this particular day, just hogging up the space, like always, taking up the space that makes the report harder to view. So I was trying to figure out how do I make the report look the way I want it to look, to get information that I want to see without anything else on there that I don't want. So that's kind of what I was just
sure.
dealing with, and trying to understand better what I was going to come up with.
Yeah, and you can't hurt anything by experimenting with it. You can't break it, and you're not gonna hack into the CIA and set off World War III. You're not gonna happen. You're not that powerful yet. So
Hopefully I'm not really.
it's just not happening. You just usually in the programming classes, students say, "Oh, I'm afraid to kind of try that. I don't know what's going to happen." Well, I'll tell you what's not going to happen.
This question: if we have an assignment where we're going to turn something in and we upload our WMCRM database, I'm having the sense that on the list of things that are here are the things that you're interested in grading. So.
It's a big circle of
A lot
life.
of the stuff I was fooling around with, I guess is
Yeah,
what I'm saying.
it's a big circle of life, the stuff I'm going to talk about now, you're going to do in that
Right.
later
And
on.
when I turn it into you, that's what you want to glance over there and see, not all the things that I was trying to.
Yeah, and if you want, and you might feel more comfortable doing this, is make a backup copy of your database. So like at the end of every Access Workbench exercise, make another copy of it so that when you continue on, if it all falls apart, you can go back and
Where I was.
get the original that you started with and try it over again. That's the worst thing that can happen to you is you get it so fouled up that you can't kind of put it back together. Not that it's impossible to put back together, just that you don't have the experience.
What has happened to me, because there was one point where I had kind of fouled up, so I had some of the information on a different database. So then I had to figure out how to get it on to the one I just, whatever. Because I figured that it was something you'd call on and say, well, I want to see this.
So you had to export it and import it.
Copy and paste, because you had taught us that last week, and I did it, and renamed it, and got it where it needed to be, and I was like, oh, see, now this looks like it's supposed to.
Good. I mean, that's how you learn stuff, That's how you learn stuff. I had a student in the last class, they were supposed to write a program that was supposed to take a text file, plain old text file, that was called words.txt. Well, when she saved it on her hard drive, Microsoft, Windows, decided when she typed in words.txt, Microsoft changed it to words.txt.txt, and then she couldn't understand why her program wouldn't open the file. She's looking in her folder on her hard drive, and it says word.txt. Of course, it doesn't tell you the underlying extension .txt is also on there, and we finally found it. But she went through a lot of trouble getting that to work. And
That's when the help isn't helpful.
that's when, and
I don't like it when you decide what I was trying to say.
I don't like it when my computer thinks it's smarter than I am. I know what I'm doing, just do what I tell you.
I don't know what I'm doing.
And don't complain.
I don't need a lot of stupid help.
Well, yeah, don't try to help me out. Don't try to help me. You're not, my brother has a saying, you're not helping, Just whenever.
I said that about my sister-in-law, because she was the most helpful person on earth, and I was like, keep her away from me. That kind
So-
of help isn't helpful.
Anyway, to answer your question, this is the QBE screen that you'll see when you get to that point. Query by example is what it is. Sometimes there's, I think they call it a query wizard. There's a query wizard, but the query design is so easy, I never use the wizard. The wizard, you just answer a bunch of questions and it creates it for you, but the design view is so easy, it's just, why not do it that way? All right, oh yeah, let's see if we can create a table. Let's create another table of, we'll call them professors. And we're going to do this using SQL. So just so this doesn't give me a hard time, yeah, go ahead and save it. Let's close all these things. Yes, save it. Close. I'm going to create a query, and I'm not going to add any. I'm just going to close that. And I'm going to change my view to SQL view. Now, instead of doing a select, I'm going to do a create table. Now, in the old days, if you wanted to create a table in a database, you had to actually use a command, create table. Then you got to give it a name, the name of the table. Oop, keep doing that. And then within that, let's see, now we have a curly brace. And then in here you have your field list, which encompasses the field name, field data type, and any restrictions that it might impose on that. Okay. So let's create a field, a table of professors that we will link in to our other table, the rest of our tables. So create table professor. All right, and I'm going to try to make this readable as we go. Next line. Now, for the field list, we have these curly braces that cordon off all these field names. So let's do this. So the first one, I want to say Professor ID. Okay. And I'll say character 30. Oh, no, I don't want 30 for that. Let's just do 5. And then the restrictions I'm going to put on is primary key, comma. So that's my first field. It's the same way as I did it. So when I'm using SQL, I can use, some versions allow you to use text, some allow you to use character, and then a number for the size of that. So let's see. Then I want to have name. That'll be my character 30, comma. And then, how about department? D-E-P-A-R-T-M-E-N-T. Department. And make that a character 30. Let's see. All right, let's leave it at that for now. So I don't need a comma after my last field. Or yes, I do. That's weird. Wow. Oh, hold on. Curly, not a curly brace. Parentheses. That makes a difference. And then at the end of it, a semicolon. So create table professor, and then there's a couple of examples of this on page 128 in your book. You don't have to go look at it now, but of how they created different tables. So I should be able to run this thing, fingers crossed. Now, one of the things about creating tables using SQL, if it kind of half works, you have this table that isn't exactly what you want, but it creates a table. So you might have to go and delete the table to to get past that. So I'm going to run this thing. Field definition. Which one? I think I don't need that run. Created it. I didn't need that last comma. The book has a comma after the last field. Do not need it. So I said professor, create table professor, parentheses, professor ID, character 5, primary key, name, character 30, comma, after primary key, comma, name, character 30, comma, department, character 30, no comma, close parentheses, semicolon. And it created that. Now if I look at that, there we go. And now I can go in and add whatever data I need to. Let's see how we do that. Got it? So let's end right there on that point. I'm going to save all this, and we can kind of add to it next time. I think next week we're still working with SQL, if I'm not mistaken.
Yeah, so.
Cool. So we can do some more more stuff, maybe a few more selects, maybe do some group bys. But if you look at the SQL code that's in this chapter, it's pretty easy to figure out what it does, you know. There is one, if you get a chance to look at, make a note, on page 142, inserting data, or on page 140, inserting data, it starts talking about that. They have a statement that says insert into department values, and then it gives the values of the new record. So it's adding a new record to the table. It doesn't, there is a version of that allows you to specify the field names, insert into department, I think it's fields, and you list the field names. So, and then values, and you list the values for the corresponding field names. If you don't list the field names, you have to know the order in which the fields were created in the table. And then if you had to do this on a large database that you didn't create, you won't know. So I'm going to try to do a little research on the specifying fields. Because if I say insert into professor, fields, name, department, professor ID, values, Smith, business, 1, 2, 3, 4. It will correspond the field names to the values that I put, because the first set is the field names, the second set is the values, and it will just correspond them. But if I said insert into professor, Smith, business, and then 1, 2, 3, 4, what it will do is it'll put Smith in professor ID, it will put business into name, and it will put 1, 2, 3, 4 into department, because that's the order in which the fields exist. And since they're all text, it doesn't care. So it can cause problems. So you want to make sure that you get all the data hooked up correctly. All right, any questions? We good? You guys going to be SQL programmers before long?